Hi, in this session, we are going to talk about another very famous important interview question, which is also known as maximum sum contiguous subarray problem. So in this problem, we'll first see that what is the problem statement, and after we discuss the problem statement, I would like you to first try the problem on your own before you just go ahead and see the solution. If you're not able to do it, then obviously you can come back and see that how we are solving it. And when we are solving it, we'll first try the brute force approach, and then we will see that how by storing some values or doing some sort of optimization, we will come up with the optimized approach, and that will take us to another very famous algorithm. So I'll just tell you about the algorithm when we go ahead and talk about that algorithm. So this particular session will help you come across that particular algorithm as well. So let me first make you understand the problem statement. So as you can see in this particular problem, you're given an array. So the array is having some set of integers. So what you have to do is you have to give me the maximum sum contiguous subarray. So basically if we talk about subarray is a part of this particular array and all the elements should be continuous. So if we see what are some of the subarrays, then this is a subarray. This 10 minus 20 is a subarray. This 10 minus 20, 35 is a subarray. So this 10 minus 20, 35, 40 is a subarray. This complete thing is a subarray, or for that matter, if we start from here, this is a subarray, this is a subarray, again this is a subarray. So basically any part of the array is a subarray, and when we say it's a contiguous subarray, generally subarray means that in this particular subarray the elements should be continuous. So in this case 10 minus 20 is a subarray, but if we try and do 10 comma 35, this is not a subarray because obviously 10 and 35 are not contiguous, right? So just now we have seen what is a subarray. Then obviously if I am given this particular array, there are multiple such subarrays possible. So as we showed you some subarrays, what you have to do is you have to give me the largest sum we will get by adding elements of the subarray. Okay, so let's say in this case, let's take out some subarrays. We won't be going through all the subarrays, let's say. So let's say 10 is one subarray, 10 minus 20 is a subarray, 10 minus 20, 35 is a subarray, or 10 minus 20, 35, 40 is a subarray. Similarly, let's say minus 20, 35, 40 is a subarray. So there are multiple such subarrays possible, right? So I've just taken few subarrays, and if I do the sum of all the elements in the particular subarrays, so in this case the sum is 10, in this case it's going to be minus 10, in this case it's going to be 10 minus 20 plus 35, it's going to be 25, in this case it's going to be 75 minus 10, 65, in this case it's going to be 75 minus 20, 55. So as you can see that out of all these subarrays, the maximum sum is 65. The maximum sum is 65. So you have to return this particular sum. So you will be given an array. An array can have multiple subarrays, and you have to find out that out of all the subarrays, which particular subarray is giving me the maximum sum. So you know the problem statement. I would like you to first try the problem, and then you can come back to see how we are solving it. So I hope you tried the problem. So let's see how we can just start with a very brute force approach and then we optimize it, okay? So if you have to solve this particular problem, so basically the problem is that you have to find the subarrays, or let's say the problem is that out of all these subarrays, the sum that is possible, you have to give me the largest sum. Okay, so if you think something that what is the easiest thing that you can do, or what is the first thing that comes in my mind? So the first thing that comes in my mind is I'll find all the subarrays that is possible, and I'll just add all the elements of all the subarrays that I found out, and I'll just compare who is the largest one, right? So let me take a very small array. So this is a kind of a large array for telling you what I'm talking about. So let's say the array is 1, 2, 3 and 4. Okay, so as I said that what we will do is, well, we'll find all the subarrays that's possible. So let's see what are the different subarrays possible out of this. So number 1 is 1, then we have 1, 2, 1, 2, 3, 1, 2, 3, 4, 2, 2, 3, 2, 3, 4, 3, 3, 4 and 3. So now what I have done is I have found out all the subarrays, and I'll just simply add all the elements of these subarrays, and what I'll do is I'll simply calculate which is the largest one. So this is one approach. So okay, fine, the approach is not the most optimized one, but let's see if you have to code this approach, what will you do? So in order to code this approach, as you can see, what you're doing is you have you have a starting point. So as you can see that what we did, we first took all the subarrays starting from 1, we took all the subarrays starting from 2, and then from 3, and then 4, right? So we need to have a starting point. So let's say I start my loop from I equal to 0, and the loop goes on till n. Okay, because this will take care that we are starting the subarray from all the elements of the arrays, right? It could be either this, or this, right? Okay, so this is one loop, I know for sure, which takes care of the starting point. Now we have to have a loop which takes care of the ending point, right? So again, if you can see the end, if you start from 1, the ending could be either at 1 or 2 or 3 or 4. So we'll have another loop that starts from I, because if we are starting from, let's say, 2, then obviously the start point has to be 2, not from 0. So we'll have j equal to I, j will again go till n, j plus plus. Okay, so now we know that this is the starting point and this is the ending point. Let's say we know that how we can just go from starting to ending point, but we need another loop that iterates through all the elements in that particular subarray. So let's say in this particular subarray, this I takes care that the subarray will start from 1, and this j takes care that subarray will end at 3. But now I need another loop that iterates through all the elements of the subarray that starts from here and ends till here. So we will need another subarray that starts from I and it goes till j. Okay, so now what we have to do is we have to add all the elements in this subarray. So we will keep a variable sum which will have value as 0 initially, and we will need another variable max sum. So the max sum is keeping track of the maximum sum till now. So let's say we have initialized max sum somewhere here. Let's say it is initially int min. Okay, so what we will do is we'll just keep on adding the elements of this subarray that starts from I and ends at j to this sum, right? So we will have sum equal to sum plus a of, so let's say this is arr. Okay, so this is plus arr of k. Okay, and when this particular loop is closed, so what happens after this particular loop is closed, we got the sum of that particular subarray. So let's say whether it is this sum array, this array, or this array, right? We got that what is going to be the sum. Now we have to check that if this sum is greater than max sum, we have to update our max sum, and the max sum becomes sum. So what is happening here is that this takes care of the fact that, okay, max sum is always having the value of the maximum sum. Okay, so if we see what is going to be the time complexity, so since we have 3 loops and these are nested loops, we will have the time complexity as O of n cube in worst case scenario. Okay, and if we see what is the space complexity, we are not using any extra space, so the space complexity will be O of 1. So now the question is, can we optimize this further? Is there any way I can do the optimization? Okay, so let me just go back to see what this particular thing is doing, so that we see that whether I can optimize, So whenever we have to optimize, one obvious way that comes in my mind is that, can we just maybe use the results that we have already done, or maybe can we, reduce the number of redundant operations we are doing. So let's see if we are doing some sort of redundant operations over here. So as you can see here, what we did, we calculated the sum. Okay, so let's say we have something called sum, right? So we initially added 1 to the sum, then we added 2 to the sum. So as you can see that this is common, right? Sum contained at this place also sum had 1, at this place also sum had 1, and 2 was added. Here also 1, 2 was already there, 3 was added. Here 1, 2, 3 was there, and 4 was added. So if you see that if there is this sum, initially sum is 1, then our sum becomes, we can just write that sum is equal to initial sum plus the element there. Similarly here what we can do is, rather than just going back here from 1, 2, 3, we can just use this particular sum and add 3. Similarly here, rather than again going to 1, 2, 3, 4, we can use this sum and just add 4. This will give me the latest sum. So what we are doing here is, we are calculating the sum again and again. So if let's say we have 1, 1, 2, 1, 2, 3 and 1, 2, 3, 4. What we do is, when we are in this particular loop, we calculate from j is equal to I to less than n. So let's say my I is initially 0. I just keep the sum as 1. And then what I do is, I just simply do sum plus a of or arr of j. that gives me the latest sum. Let's say it's the latest sum, and then we do sum plus again arrow of j. So if we do this particular thing, we will not need this particular loop. So we can simply remove this particular loop. So let's see how our code looks if we remove this particular loop. And obviously if we remove this particular loop, we'll have O of n square as the time complexity. So let's see that particular code. So now what we are going to do is we are going to write code for n square. Okay, so I'll just repeat. We had 1 2 3 4 as the array. We had 1 1 2 1 2 3, and rather than generating the sub arrays again and again and going from beginning to end, we will utilize this particular sum to calculate the next sum. So again in this case, we will have for I, we will definitely have to have a variable for the first element. We'll have from I equal to 0 to I less than n and plus plus, and then we have j is equal to I to j less than n, j plus plus. And here is the change that we are doing. What we are doing is we calculate sum. So let's say I keep my sum as 0 here. So I calculate that sum plus is equal to array of j. So initially when we are here, let's say it's 1, I is 0, we'll have sum as value 1, right? And then what happens is that I check if sum is greater than max. If it is, I update my max equal to sum, right? And now what happens is that let's say our j increases to this particular place. So now my sum becomes sum plus, which we already had, plus 2, which is 3, right? I again do this checking. Then j comes here. I again do the same thing. We have 1 plus 2 plus 3. And then my j comes here. We have 1 plus 2 plus 3 plus 4. Similarly, when I changes to 1, we have first our sum will have value as 2. Since it's 0, then obviously here it will get updated. Then 3, then 4. So what we did just now, by utilizing the previous information or utilizing the sum that we have already stored, we reduced our time complexity from O of n cube to O of n square. So I would like you to think more that now let's say if I have to reduce the time complexity to O of n, what we can do.
Okay, so till now we have seen O of n cube solution, O of n square solution, and now we are going to talk about O of n solution. This particular solution is also known as Cadane's algorithm. So let's try to understand what is this and how do we approach this. So let's say this is my array, and what we do is that we see individual element. Okay, so let's say we come at 35, and let's say our sub array that is giving me the maximum sum ends at 35. Okay, so I'm just telling you that let's say that the sum is going to be that the sub array which gives me maximum sum is going to end at 35. So if it is going to end at 35, what is the option that we have? What are the options that we have? Number one option that we have is that whatsoever is the maximum sum till here, till one place before 35, whatever is the maximum sum till here, we will use that. So let's say if it is sum, we will use this sum plus 35, that will give me the maximum sum that ends at 35, right? This is one option. Another option is, let's say this sum is going to be something in negative. So if you see this particular way, this sum is going to give me minus 10, right? So if we do minus 10 plus 35, then obviously this is 25. And if we just use 35, it is going to be greater than 25. So for any element, I just see that, okay, what if this particular element is going to be endpoint of the sub array that is going to give me the largest sum? We have two options. Number one option is that whatever is max till now, plus the current element. Another option is just the current element. And now what we do is that, so let's say we are at 35. As we saw that we took whatever is max till now, we had minus 10 was max till this particular place, and then we had current, so that gave me 25, and this just current gave me 35. So now max till this particular place, max till 35 actually becomes 35. So max till 35 is 35. For now, for 40 again we have two options, that either we just have 40, let's say the subarray is going to end at 40. For 40 we just have one option, either we just have 40, or what we do is that we use the sum that has been there, maximum sum till 35, and we just add it. So this gives me 75. So as you can see that in this case, adding this sum that has been maximum till a place before 40 gives me the better result. So I'll just keep as 75, right? So now what happens is that for any particular element, we just have to see that if this is going to my endpoint for the maximum sub array, whether I should include whatever has been the maximum sum till now, let it be, or I should just have that particular element. So let's just do this particular operation from beginning and see that how things are going to happen. Okay, so let's start from the very beginning and try and do the operations. That will make things even more clear for you, right? And what we will do is we will also keep something called max. So this max will give me at the end of the day the maximum sub array sum for this complete array, and then we will have something called max so far. So this max so far will give me the maximum that has been there till that particular element. So let's say initially we initialize both max and max so far as 10. Okay, since 10 is the first element. Now we go to minus 20. At minus 20 we have two options, that either we have this max so far plus minus 20, or we just have minus 20. So basically what I'm doing is I'm calculating the maximum that we can have if we have just these two things, and this is going to be my endpoint, right? So in this case, this gives me minus 10 and this gives me minus 20. So obviously what happens is that minus 10 is better than minus 20, or it is greater. So we update our max so far for minus 10. And obviously when we do this, we also check for every point, that we also have to check that whether the sub array sum that is ending at minus 20 is going to give me the maximum sum, or 35 one is going to be the maximum sum. So for every iteration we will also check that whether this number, whatever is the maximum so far, is it going to be my maximum for the complete array. So we keep on checking in every iteration that whether this max so far is greater than max. If it is, I'll update it. So in this case that is not the case, so we'll just let it be. Now our max so far becomes minus 10. Now we come here, again we have two options. It's either going to be minus 10 plus 35 or just 35. So obviously minus 10 plus 35 gives me 25 and this gives me 35. So I'll just use 35, right? So my max so far becomes 35, right? Now what we do is we check this 35, we compare with maximum. Obviously 35 is greater, we update our max to 35, right? Now what we do is that we come at 40. Again we have two options, to use this max so far or to ignore this. So since if we do 35 plus 40, that gives me 75, which obviously is greater than 40. So what I'll do is I'll use this 35 and 40, and our max so far becomes 75, and I update my max as well, which becomes 75, and max so far till 40 is 75. Now what we do is we come here at 10. Now at 10, again we do 75 plus 10, that's going to give me 85. So now my max so far, which is still 10, gives me 85, and that is also going to update this max to 85, right? Now we again proceed further. Minus 10 is the case. So if we come here, minus 10 gives me 75. So we have two options, we either have 75 or we just have minus 10. No wonder 75 is the largest one, so I'll just have this max so far as 75 till 10. Now I compare this with max. Is this less than 75? No. So I just leave it like this. Now we come here at 100. So again if we do 75 plus 100, it's going to be greater than 100, right? Now let's do one thing. Let's make this minus 100. Let's make this minus 100. Now what happens is that we calculate 75 plus minus 100. That is going to give me minus 25, right? And another option we have is just minus 100. Obviously minus 100 is less than minus 25. So our max till here becomes minus 25. And obviously our max, this one is not updated. Now we come at minus 20. We have two options. We have minus 25, minus 50. Basically plus minus 50, which gives minus 25 minus 50. This gives me minus 75. Or we just have minus 50. So our max so far becomes minus 50. So obviously this is less than the max that we are having. So this gives us max as 85. So that is what we are doing. For every point, we are calculating that what has been the max so far. So basically for every point, we already have the maximum sum before that element, or maximum sum before that element, and we have to calculate the maximum sum considering that this element is going to be the endpoint, and for that we have two options. So this is what we are going to do, and we are obviously using the results that we have already calculated. So as you can see that when we are here, we are already using the results that we had calculated till this particular place, and this is what is known as dynamic programming. So just now we used dynamic programming to solve one of our problems. What we did in this particular case, we utilized the results of the subproblem. When we are saying that what if this minus 20 is going to be the endpoint. So this is like if you just forget about this place of array, this particular part of the array, my subproblem is just to find maximum sum in this particular array. So max so far is actually giving me the maximum of a subproblem. Using these results of the subproblems, we're actually calculating the max. So now let's say if we have to write code around it, how are we going to write that? So let's just go ahead and see that. So now let's just try to write the code for whatever we have seen till now. So we had two variables which we already saw. Let's say it's int max equal to a of 0 and max so far is going to be a of 0. Now I start my iteration from I equal to 1 and I go till n minus 1. And what I do is at any time I check that max so far. So basically what we have to do is we have to, let's say when we are here, we have to find that what is going to be the max so far if the endpoint is this particular place. So I check that this is either going to be that particular element, which is let's say array of I, or it's going to be max so far plus a of I or array of I. Okay, and every time we calculate max so far, we check that if max so far is greater than max, then we update our max to max so far. So as you can see that the coding is pretty simple if you once come up with the approach, and the time complexity for this is going to be, as you can see, that there is just one loop and it is going to iterate just once for every element. So basically we are going through every element just once. So the time complexity is going to be O of n. And the space complexity, since we are not using any extra space, is going to be just O of 1. So this is what is Cadane algorithm, and it was a dynamic programming based approach. So as you can see that we didn't directly jumped into that particular approach. We first solved brute force, and then we eventually got a pattern that okay, even this thing might happen. So initially we were storing sum, and then we eventually what we did, we started using this max so far to optimize our approach.